A projectile is just a body which is in flight through an atmosphere but not being propelled by any fuel. So such type of bodies you can take next way as a projectile. Examples you can see a bomb released from the aeroplane and a bullet fired from the gun and an arrow released from the bow and a javelin throw by the athlete. These are all the examples of projectile. Okay. Next one, go with the assumptions of projectile motion. So next concept is assumptions. Assumptions of projectile motion. So majorly we are consider four different types of assumptions. Number one, there is no air resistance. There is no air resistance. Next, second one, the effect due to curvature of Earth is neglected. The effect due to curvature of Earth. The effect due to curvature of Earth is neglected. Means surface of Earth is remains parallel to each other. And third assumption is the effect due to rotation of Earth is negligible. The effect due to rotation of Earth, rotation of Earth, neglect. And fourth one is acceleration due to gravity remains constant. Acceleration due to gravity remains constant. So these are all the four assumptions we need to take in for the projectile motion. Copy this one. Projectile into two dimensions. One is along the horizontal, one more is along the vertical. And second one, along the horizontal, second observation, along the horizontal acceleration equal to zero. Means body is in, means a projectile is in uniform motion. Why? Because acceleration equal to zero, na? Therefore, projectile is in uniform motion. Next, along vertical acceleration due to gravity will be present. So, along vertical acceleration along y direction, we can take next way as a minus g. Means all kinematic equations we need to follow. All kinematic equations are valid along vertical direction. Next, horizontal motion is uniform and vertical motion is uniformly accelerated. Okay, and there is no dependency on the horizontal motion with the vertical motion. That's why the total the 3 points you can take next way as a principle of independence. There is no dependency on horizontal motion on vertical motion, or there is no dependency on vertical motion on the horizontal. Horizontal motion and vertical motion both are independent to each other. That's why the projectile motion will be independent in two-dimensional way. Okay, copy these 3 points. Principle of physical independence of the motion. Copy it, Babu. See here, three different types of projectiles are there. First one is oblique projectile, or you can take in ground to ground projectile. Second one is horizontal projectile, and here body will be projected with a certain horizontal velocity from the height, and the projectile motion on inclined plane point of view. And here ground is not taken as to be as reference. Inclined plane we need to take as to be as a reference. On this plane, a projectile which we projected with a certain initial velocity, taken that initial velocity u, and it makes an angle theta with the incline. So first, here we will discuss the oblique projectile first, and then we will go with the horizontal projectile. And last, we will go with the projectile motion in inclined plane. See, first one, oblique projectile. Oblique projectile. So you can take in, it is your reference, ground reference. And here your observer will be sitting taken as to be as origin O. And he is thrown the object with a certain initial velocity u. And it makes an angle theta with the horizon. Already we know that acceleration along x direction equal to 0 and acceleration along y direction equal to minus g. So minus g. Therefore, along the vertical direction uniformly acceleration, and along the horizontal uniformly motion, or that is uniform velocity. Therefore, the body will be projected like this. Okay. Now, first we need to do here, resolve the motion into horizontal and vertical. So first we need to take resolve the motion into horizontal and vertical. See how it will be do. First I will take in velocity along the horizontal, component of u along the horizon. So u theta component. So u theta component is u cos theta, and u 90 minus theta component means in this direction, vertical direction, you got u sin theta. Uh, Acceleration along x-axis is 0 and acceleration along y-axis is 0. Now, here we need to find out the some terms belongs to oblique projectile. First one is first one is time of flight. Time of flight denotes with capital T. So denotes with capital T. So time of flight you can define as time to reach. So time to reach ground. Time to reach ground. You can take it as a time. Now time to reach the ground from the point of projection or from point of projection. Point of projection. See, in the time of flight, object initially on the ground and object finally on the ground. Therefore, within the time of flight, the vertical displacement traveled by the projectile equal to 0. So, therefore, Sy you can apply uy times of time t plus half ay times of t square. Why? Because along vertical direction accelerated case. So, within delta t, so within time t equal to, so within time t equal to tau or t, Sy equal to 0. So a uy, so uy you can take as b as u sin theta, and ay you can take as b as a minus g. So ay is minus g. Substituted these values in this equation. Sy equal to 0, that equal to uy is nothing but u sin theta. U sin theta times of time t is capital T plus half a value you can take as a minus g, and t square you can take as a capital T square, where t square and t get cancelled. Therefore, so g times of t divided by 2, that must equal to u sin theta. So hence, time of flight from this equation you got time t equal to, so 2u sin theta divided by g. That is the time of flight of an objective oblique projectile when if you are projected an object with initial velocity u makes an angle theta with the horizon. Copy this concept. See, range of projectile. Next word. So you can write over here range of projectile. See, range of projectile is nothing but it is horizontal distance traveled by the projectile in a time of flight. Horizontal distance traveled by the projectile in a time of flight you can take as well as a range of projectile. So therefore, range of projectile is nothing but ux times of time t. So where ux is nothing but u sine theta, and the time is nothing but, so 2u, no, ux is nothing but u cos theta, and time is nothing but 2u sine theta divided by g. 2u sine theta divided by g. Now, if you are taking this formula is u and u square times of 2 sine theta cos theta, 2 sine theta cos theta divided by g. So already you know the formula. So 2 sine theta cos theta. So you know that 2 times of sine theta cos theta. So you can take in as to be as sine 2 theta, sine 2 theta. So substituted over here. Therefore, range of projectile you can take u square sine 2 theta divided by g. That is the range of oblique projectile. Formulas you can keep in properly, Babu. Based on formulas, we will solve the problems. Okay, copy this one. Next, you can go with the maximum height reached by the projectile. And one more concept here, maximum height reached by projectile. See the projectile diagram. So here, body will be projected in this way, and at this location, final velocity along y direction will become 0. At the point, so you can take in the height, you can take as well as the maximum. At the maximum height of the projectile, vertical component of velocity will become 0. Now, we can apply the formula v square minus u square equal to 2as. So apply v square or vy square minus uy square, that must equal to 2 times of ay into sy. See, at maximum height, vy equal to 0. And if you taken ay equal to minus g and sy equal to, so sy equal to capital H, and initial velocity along y direction of a projectile. So uy is nothing but u sine theta. Substitute these parameters in this formula. Vy square is nothing but a 0 square minus uy square is nothing but a u square sine square theta, u square sine square theta, that must equal to, so 2 times of acceleration is along minus y direction, and the displacement you can take as a maximum. Now, if you are further extend na minus u square sine square theta, so minus u square sine square theta, that must equal to minus 2g times of h maximum. Therefore, minus and minus if you are common out na, so you got h max equal to, so maximum height equal to u square sine square theta by 2g. So u square sine square theta by 2g. So it is the maximum height reached by the project. Okay, copy this one. Maximum height reached by the projectile. So three different quantities I am given up to now. First one is time of flight, second one is range of projectile, and third one is maximum height reached by the projectile. Copy this one. See, next concept, trajectory equation. Trajectory equation of projectile. So trajectory equation is nothing but, it is just a relation between x coordinates and y coordinates. X and y coordinates of projectile. Relation between x coordinate and y coordinate of projectile. Okay. Now here you can take, it is your ground, and the point of projection if you take next way as a origin. From the origin, if it is projected with a certain initial velocity u, and it makes an angle theta, and if you resolve u into along horizontal, you got the u cos theta, and along vertical, so you can take in here it is u sine theta. Now, if you take as well as horizontal, along x direction, acceleration along x axis equal to 0, along y direction, acceleration along y direction equal to minus g. Now, along x direction uniform motion and along y direction is uniformly retarding motion. Now, the projectile will be moving in this direction. So, at a time t, let us say for example, here you can take in time t. At a time t, we need to take an x component of projectile as well as y component of projectile. X component, if you take as to be as x, and y component you can take as to be as y. We need to make a relation there between the x component and y component of the projectile. That is your trajectory equation. Now you can see at a time t, at a time t, x component, x component. So you can take an x. So at a time t, x component is nothing but distance traveled by the projectile in a time t. Along the x direction uniform motion, therefore velocity along x direction times of time t. Velocity along x direction you can take in u times of cos theta into time t. So u times of cos theta into time t. From this equation, time t equal to x divided by u cos theta. Why? Because time we need to eliminate. Therefore, you can take in this equation number 1. Now, along y direction, y component. Therefore, y component y equal to y, because along y direction it is uniformly retarding motion. Therefore, you can take in uy times of time t minus half times of ay into t square. Now, uy is nothing but u sin theta times of t minus half ay is nothing but g times of time t square. That is your y component. Now, you can take this equation number 2. Substitute time t equal to x divided by u cos theta in equation 2. See, here I am written equation 1 in equation 2. Equation 1 in equation 2. Then what do you got? See, what do you got now? So, y equal to u sin theta, y equal to u sin theta into time t is nothing but x divided by u cos theta minus g divided by 2 times of t square is nothing but x square divided by u square cos square theta. Now here u and u get cancelled. You got y equal to tan theta times of x minus g divided by 2u square cos square theta into x square. Compare this equation with y equal to ax minus bx square. So it is a parabolic equation. Okay. This equation you can take as parabolic equation. Parabola. Okay. Copied up to here. Equation of trajectory y equal to tan theta times of x minus g divided by 2u square cos theta times of x square. Or you can take in this equation is y equal to ax minus bx square. It is a form of parabola. Now here you can see further we will extend this one. Equation of trajectory y equal to tan theta times of x minus g divided by 2u square cos theta into cos theta. You can write like that, cos theta into x square. Now for this term alone, you just multiply with sin theta divided by cos theta. Sin theta divided by sin theta. Just multiply with sin theta and divides with sin theta. Then what you got now? What you got now? Sin theta divided by cos theta. You can take next to be as a tan theta. 2 cos theta sin theta, you can take next to be as sin 2 theta. So further you can extend it this one. So tan x minus g times of x square tan theta, x square tan theta divided by u square times of 2 sin theta cos theta, 2 sin theta cos theta. Now 2 sin theta cos theta you can write as sin 2 theta. Therefore tan theta into x, so tan theta into x minus g tan theta g tan theta times of x square divided by u square sin 2 theta, u square sin 2 theta. Now u square sin 2 theta divided by g you can take as a range of projectile. Therefore you can take in tan theta times of x minus tan theta times of x square divided by range of projectile. Just you can common out x tan theta. So you got 1 minus x upon r. So it is also a trajectory equation of a projectile. So x tan theta times of y minus r. So it is also you can take a trajectory equation of a projectile. Okay.